The next question number 7. A chord of a circle radius 12 centimeters subtends an angle of 120 degree at the center. So if you remember, in all the previous question it was just 60, right? But now it is double, or 120 degree at the center. Okay, what are they asking us to find the area of the corresponding segment. That means if they don't say anything, we're supposed to find a minor segment, this region here, right? And how do you find this? Area of the sector, that means this, right? Area of the sector minus area of this triangle, then I'll get the area of the minor segment. Clear? Alright, so the first thing we do is try to find the area of sector, right? So you can already see the radius I've written, theta is already given to us 120. Let's find the area of sector, OA PB. Okay, what is the formula? Pi r squared theta by 360. So pi, they're asking us to use again 3.14, root 3 to be used as 1.73. Clear? So I've written our formula. 9 plus of 5 written 3.14, radius we already know 12, theta is 120, and divide by 360. So let's start dividing. 0, 0, 12 1 12, 12 3s are 36, and 3 1s are, and then 3 4s are 12. Then I'll be left with what? 3.14 into 4 into 12, which when you multiply you'll get the area of the sector. That means now we've got this region, okay, to be equal to 150.72. Next we'll try to find the area of this triangle. Okay, but remember, like I said, the entire angle from here to here is 120, right? So how are we going to do this? We'll draw OM, right, perpendicular to AB. So remember, when this cuts here, it is right in the middle, so that the entire angle, this is 120, right? This will become 60, even this will become 60. Okay, and here we'll be using trigonometric ratios to find the area of this triangle. Okay, so let us have a look here. So once again, look at the given the proof. In triangle OAB, we draw OM, right? OM perpendicular to AB. That is why now this angle has become half, 60 and 60, right, in place of just 120. Clear? Now when you look here, can you see that there are two right triangles? This is one right triangle, this is the other right triangle, right? And if you notice here in this triangle OAB, there is a height and there is a base. So if I know the height and the base, we just have to put it in the formula. Area of triangle equals half base into height to get this entire area. Okay, so I'll try to find both the height and the base. Clear? So now if you look here, I've taken one part of here and drew it here, right? So like I said, we'll be using a trigonometric ratios. Clear? So you can already see theta is here, right? Which means these are perpendicular, these are base, and this becomes our hypotenuse. So first we'll be trying to find this this, okay, the perpendicular. Let's try to find the length from here to here. Clear? So we'll be using sine, and you can already see sine, how many degrees? Sine 60, right? Then sine 60, what are two sides? Perpendicular by hypotenuse. All right, perpendicular by hypotenuse. Now let's put the value. Sine 60, what is the value of sine 60? Root over 3 by 2, right? And I'm trying to find this AM, right, the perpendicular, and then the hypotenuse is 12. So I'm just putting the value. Now remember, I'm trying to find this AM, so this 12 will go up, right? So it will become now 12 root 3 divided by 2, which I can divide 2 1s and then 2 6 are 12. Clear? So I'm going to get here what? 6 root over 3. So remember, because this OM is perpendicular, it is right here in the middle, right? So if this much is 6 root 3, even this is 6 root 3. That's why you can say equals BM. Clear? So now we already got this side, right? So when I add the entire length, that is AB is made out of what? AM plus MB or BM, right? They're both same. So 6 root over 3 plus 6 root over 3, I'm going to get 12 root over 3, which means from this triangle I've already got the base. Now let's try to find the height. Okay, so once again the same diagram. Now remember, I'm trying to find the height now. Okay, so here we'll be using cos 60 degree. What are two sides for cos? And the right angle triangle will look like this, right? And because the theta is here, base, perpendicular, and hypotenuse, you can already see. So the formula for the two sides for cos is what? Base by hypotenuse, right? So you can already see I'm trying to find this OM. Clear? So sine 60 equals base by perpendicular. Now what is the value of cos 60 degree? It is 1 by 2 or half, right? I'm trying to find OM. Then AO we already know is 12, right? So once again this 12 will do cross multiplication, it will go up, it will become 12 by 2, or 2 1s are 2 6 are 12, right? Then I'm going to get OM, which is the height of the triangle here, to be equal to 6 centimeter. Now if you'll notice, I know the base, I know the height, which means I can just directly put it in the formula, half base into height, right? So when you look here again, remember this is the base. I already got the value. 6 root 3 plus 6 root 3 equals 12 root 3. The height we just found now to be equal to 6, right? So simply putting in the formula, half base into height. So the base is 12 root 3, and then the height is 6, right? And 2 1s are 2 6 are 12. You just have to multiply these 3. Then I'm going to get the area of the triangle, this entire triangle to be equal to how much? 62.28. Clear? Now we know everything, so we just have to put it directly in a formula of area of minor segment, right? How do we get again? Area of the sector minus area of this triangle, right? So area of sector minus area of triangle. We already got the value of area of sector is 150.72, and then area of the triangle OAB is 62.28, which when you subtract, we'll get the area of this minor segment to be equal to 88.44.